So let's go over the quiz together. The first problem is something we did not test in quiz 4. And this problem, if I try quick substitution, I realize it's 0 squared times sine of 2 over 0. So conceptually, 0 times sine of infinity. Sine is a periodic function, so when I'm approaching to infinity, I'm not really going to a particular number. I don't know what's 0 times something I don't know for sure, so we need to try something else. Well, one very clear sign to use squeeze theorem is the function has a very clear bound. So the sign of whatever, it doesn't matter what you have here, must be bounded by -1 and 1. And because this is a x squared we are talking about, and x is approaching to 0, so I know for sure x squared is going to be strictly greater than 0 when x approaches 0. Hence, I can multiply a positive expression to my inequality without worrying about change the sign of my inequality. If I cannot guarantee this being positive, then I cannot just multiply it without thinking about this is positive or not. Well, once I have this, I take limit as x approaches 0 for every piece of it. The left side clearly is 0. There's nothing I can say about the middle because I just don't know what's the value yet. And the right side is limit of x squared clearly 0. So by squeeze theorem, and also because this is clear enough, if something is greater than or equal to 0 but less than or equal to 0 as well, so the limit of my question must be 0. You could have said by squeeze theorem. So this is my final answer. And if we look at the second problem here, the intuition is substitution, so I end up with root of 4, which is 2, minus 2, which is 0. And then I have root 1 plus 4, which is 5, over 1 minus 1, which is 0. So this is a 0 over 0 type of problem. Well, I guess my question is, when we try to discuss this in class and also in the last quiz, we emphasize the fact that you should only get rid of the 0 term. I don't worry about the non-zero terms because I can just carry them along my calculation. So can you remember our discussion from last time, right? I still have different types of ways to solve this problem, and they don't really make sense. It looks like some of you didn't really go over your mistakes if you were not able to solve it from last time. Make sure you go over the mistakes. Make sure you understand what you did not understand earlier, right? We learn from our mistakes. We just don't do something and just give up and don't look back about it. This is a learning process. We're going to test on the same thing several times. So this is the term that's give me a 0. I will expect cancellation, but I can't really factor it. So I multiply the conjugate of it, and therefore I'm going to divide by the conjugate of it just to make sure I'm not changing the problem. So by doing this, I end up with the two terms put together. It's x plus 3 minus 2 squared, hence 4, multiplied by root 4x plus 4, and nothing changes to my denominator. So I'm simply going to put them together like that. It's x minus 1, x minus 1, so they cancel out. And I know I'm sending x to 1, therefore I'm going to plug them in. So it's root 1 plus 4, root 1 plus 3, so it's root 4 plus 2. It is 5 on the top, it's 4 on the bottom, so this is what I get as my final answer. And I would have the same argument for the last problem, which is quite similar to what we had in quiz number 4. And we explained again on Monday of last week to say how to solve this type of problem. I'm sending x to negative infinity. E to the negative infinity is 0. E to the positive infinity is infinity. So conceptually, I don't really know where this is going. It's an infinity over infinity structure, which is not defined. What we're supposed to do, we're supposed to factor out the leading term. So the leading term is the one that makes the value the most dominant. So clearly, if it's simply positive exponent, it's x goes to negative infinity, it's e to the negative infinity, e to the negative infinity, e to the negative infinity, e to the negative infinity. They all go to 0. They can't be dominating term. So only those two pieces, and they are of the same order, so they are both dominating term. So I'm just going to factor them out. Some of you like to say I divided by both of them. They are essentially the same thing. So what's left is 2e to the 4x minus 3e to the 8x. You make sure what you have here and those multiplying together reconstruct the original problem. So I have e to the positive 8x plus 1 plus e to the positive 5x. And now send x to negative infinity. And before I do that, I do cancel shared term. So what I have is 2 minus e to the negative infinity 0, 3 times e to the negative infinity 0, e to the negative infinity 0 plus 1 plus 0. So I end up with 2 over 1, which is 2, which is my final answer. So let's look at the next problem. Well, this is looking for using the definition, limit expression of derivative definition to solve the problem. So I have h approaches 0. So I have denominator is h. I have the original function subtracted, right? And then I have slightly modified version of it. Some of you missed the parentheses, which is going to significantly change the calculation. So make sure you are writing them out properly. The next problem, we are using the definition of derivative to solve the problem. So you need to write out the definition first. H prime of x is the limit h approaches 0 for 2 times x plus h plus 1 squared plus cosine of 3 minus 2 of x plus 1 squared plus cosine of 3 divided by h. So you could have done the calculation on the side if it helps. So I have limit h approaches 0. It's h, it's twice of x squared plus h squared plus 1 plus 2x plus 2h plus 2xh plus cosine of 3 minus 2 x squared plus 2xh plus 1 minus cosine of 3. So if we were to cancel the shared term, it's 2x squared, 2xh, 2xh, and 1, and cosine 3, cosine 3. So what I have left is twice of h squared, 4 times of x, 4 times of h, over h. I think I'm missing something. My bad, I made a mistake. I'm so sorry about that. So here's my mistake. It's 2x squared plus 2x, right? I'm so sorry about that. So when I do cancellation, it's the 2x cancel with the 2x. So what I have left is 2h squared and 4h, and the 2 times 2xh, which is supposed to be 4xh. So if you look at this, you can cancel the h term. So what you have left is 2h, 4x, and 4, where h goes to 0. So you have 4x plus 4 as your final answer. So the last problem we have here is to look for the proof of having at least one solution. If you went over my review, you should realize we still have the intermediate value theorem, which we haven't touched yet. And that's exactly what we are going to have here. And I have my f of 2, which is 2 squared minus 10 times 2 plus 3, which is 4 minus 20, which is clearly less than 0. I do realize my original function is a continuous function. So by intermediate value theorem, f of x must have a root between 0 and 2, because, well, have a root means function value being 0, because the function value is less than 0 at the point of 2, and it's greater than 0 at the point of 0. So I must have something squeezed in the middle. It's very important that you classify your function, clarify your function. You tell me it's continuous, saying you are using intermediate value theorem, and also make it super clear that you are looking for something that's bounded in the middle. My bad, I should have said it's supposed to be 0. I'm sorry, I'm like rushing a little. So because it's positive on one end and negative on the other end, it's continuous, so it must go across the value of 0 in the middle. So this must work out. Okay, so here, hope this gives you some idea how to solve those problems in the quiz.